Welcome, guys. I think we are live now. Welcome again to the second session of data structures and algorithm. Before I start, let me quickly introduce myself. So this is Vishwa Mohan. I have close to 9 years of industry experience. I'm a pass out from IIT BHU. And during this 9 years of time, I have worked in the different pillars of this IT domains. For example, I have worked for the database giant. I have worked for an e-commerce company. I have worked for a PayPal, which is again a giant in the terms of payment domain. And currently I work for the LinkedIn in the capacity of a senior engineer, right? So I think the Great Learning has brought a great initiative to bring us on this platform and to bring these sessions which will help you to go through the nuances of the data structures and algorithms. So as a part of this whole course, since it's just the beginning, I'll just try to reintroduce what this course is all about. So through all these consecutive sessions, like we'll be having sessions like 3 times in a week, maybe Monday, Wednesday, and Saturday most probably. During this session, we'll be talking about the basic foundations which is needed to learn data structures and algorithm. We'll try to cover the whole linear data structure. So in the last session, we talked about the time boxing. Then today we'll be talking about the recursion. Then we'll talk a little bit about arrays, sorting algorithms, linked list, stack queue. So everything that it takes to build a strong foundation of the data structures and algorithm. This is what we'll be covering in these sessions. And mostly covering the linear data structure aspect of it. So please feel free to join, share among your friends, because I think this is a free course and you can make the best out of it. And I sincerely feel if you go through it, one thing is for sure that I can guarantee you is that you'll feel more confident as a software engineer, as a new learner, as a person who wants to crack, the data structure centric interviews. And at the same time, you'll feel more connected. You will understand the practical aspects of what a data structures and algorithm is. Said that, throughout the session, I'll also try to keep it very industry relevance. I don't want to keep it just a matter of examination or a theoretical aspect. I'll try to keep it very industrial, relevant topics, so that you understand that how these data structures are actually get to use in the industry. So this is what it is. So I think let's get started. So today's session is about recursion. Okay, so we'll try to first understand, what recursion is. Why do we need recursion, and how do we to solve the problems on the recursion. So once we understand the concept, we'll also try to solve few problems to understand the concept well. And the rule of the house is that try to keep it as interactive as possible. Whenever you have any doubt which is relevant to this topic, feel free to ask, and I'll try to pick your questions as and whenever I get time, and I'll try to answer you. I'll try to answer most of you guys, so please feel free to keep pushing the questions, right? So this is whole about. So we'll try to keep it interactive. We'll try to keep it as relevant to the industry as possible, and we'll try to focus our study of the data structures and algorithm around how it will be used for solving the real life problems, for solving the problems in the industry, and how it is relevant to from the eyes of the interviewers, right? So I think let's get started. So you as a student who is actually watching this video, you should also have some expectation, right? Because you are going to spend next 1 hour of time reading this topic. So these are the few 5 points which I feel you should expect from yourself, that at the end of this 1 hour session, you should be knowing for sure. One is that you should be very clear about what is recursion. Okay. The second thing is that how recursion is supported, right? For any language, whether you're solving for Java or Python or Scala, right? In any of this language, what is the underlying data structure which powers recursion? So that is the second thing. The third thing, we'll talk about what are the different kind of recursions that we get to work or get to use. So this is the third type. The fourth one is that is very important, because I have been talking to so many students, everybody has heard of recursion, and the only problem, and everybody understands it also. The only problem is thinking recursively. They struggle in applying the recursion in the different topics. So we'll try to also understand how to think recursively, right? And the fifth one is that at the end of this, I think you should have a better confidence, a better clarity to how and why to apply the recursion in the different problems. Now, the reason I have put recursion at the starting of this session, because recursion is one such strong concept which will be used again and again. So for example, we study recursion now, and again soon you will realize when we are reading some kind of sorting algorithm, it will be used in merge sort, it will be used in the quick sort. Then we move to the another topics like linked list. There recursion may be used for reversing the linked list or reversing in the pair, right? And as we move advance and advance, the topics like trees and graph, the 90% of the problems on the tree and the graph, you can be easily solve only if you know what recursion is. The people also fear about dynamic programming. Again, the ability to solve a dynamic programming lies how good you are in recursion is, right? So again, recursion is something which is the base of all the foundation of all the new advanced things that you are going to do in data structures and algorithm. So with that point in the mind, we have tried to put the recursion as one of the initial topics, and we'll take it from here. Okay, so I think let's get started. So let's see about what recursion is. So we are talking about recursion. So before going deep into what it is, let's try to understand what is the literal meaning of the recursion is. So if you go and see your English dictionary and try to figure it out what is recursion, it will mean that something which is repeating again and again. So I have few questions which say that we'll be discussing the solution to the assignment 1. Yes, we will be discussing the solution assignment 1. Maybe we'll take it in the in the last few minutes of the session. We'll be talking about the assignments from the previous session. There's another question as of now that can we apply these for the Python too? Yes, right. Any programming language, maybe whether it's it's Python or it's Scala or it's Java or any other language as such. This concept of the recursion can be applied in any of the language. It's very language neutral. So whatever that we study in data structures and algorithm, it's language neutral. Whatever the language is, you can always go and implement it. I'll be using Java as a medium, but you can always feel free to go and apply in the Python. And if you are finding any issues, just comment on this YouTube, whatever link that you will get in that mail chain. We'll try to respond to you as much as possible. So whatever issue that you have, any questions around that particular topic, you can just post it as a comment section in that YouTube video, and we can take it as a chat thread, a discussion thread, and we'll take up. Also, whenever you have been given any assignments, if you have any doubts, you can put your doubts in that chat section in the comment section of the YouTube video, and we'll try to pick it from there, and we can have the discussion then and there also. Cool. So let's talk about the recursion. So again, coming back to the recursion thing. So as I said, if you go and look into an English dictionary, what is the meaning of the recursion? It means something which repeats itself, right? A recursion is something which which repeats itself. A very simple example would be, if you suppose you define a function, and inside the function you call it again, right? So what is happening is that this is a function definition, and as soon as you call the function, this calls the function again, and again this will call the function again, this will call the function. So it becomes a kind of circle, right? So this function is calling this function, and this function is calling this function, right? So recursion means you're calling yourself again and again and again. This is what the literal meaning of the recursion is. Now we have tried to bring that literal meaning of the recursion into the programming world with certain constraints, So let's try to understand, what is the meaning of the recursion in the terms of the programming. So again, as I said, the meaning of the recursion is to do things again and again and again. So it is something similar to what we do in a case of the for loop, right? So I think most of you would have already aware of some kind of syntax of the for loop. And if not, I'll just give an example. So for loop is something like that. Suppose you have a number from, number from 1 to 10, and you want to go and iterate through you want to print all of them. So you want to print 1, then you want to print 2, then you want to print, and then you finally want to print 10. So what you do is that you normally set for I equals to 0, I value is less than 10, and I plus plus, and you're saying that I'm starting the I from 1 and I'm going till 10, right? So we'll first print 0, then we'll print 1, then we'll print 2, then we'll print 3, and something like this. It'll go until print 10, right? So in a for loop also, what you're doing is that you're trying to repeat the same thing one after the another, right? And basically you are doing it till the time the value of I is equal to 0 and it is become less than equal to 10, right? So that is how you're writing a for loop. So recursion is an alternate route that you have taken to solve the same problem that you're trying to solve with the help of a iterative approach. Okay, so recursion is calling itself again and again. So in the loop also we are trying to do something again and again. So there is a small similarity between the recursion and the for loop. So recursion is normally another route or another way of solving the for loop problem more efficiently and more intuitively. Now I have used two words, more intuitively and more efficiently. We'll see that how it makes sense when we see a particular problem. So again, coming back to what recursion is in the terms of programming language, it is a kind of function which call itself again and again. It is a kind of function which calls itself again and again. So with this definition, let's try to create a function recursively. So suppose if I have created a function, suppose the function is public void, and I say print name. Okay, and in this I first go and print the name as system.out.println. I say hello students. Okay, and then I call this method again, print name. Okay, now what we see here is that this is the function which I have defined, and inside the function itself I'm calling again, calling again. Now this pattern of a function in which we have defined a function, inside that function I'm calling that function again, this is known as the recursive pattern. Recursive pattern. This is known as the recursive pattern. So this is a generic pattern of a recursion in which you define a function, and inside the function you call the function again. So I have defined this function in print name. I'm calling this function again inside this. Now this particular problem has some issues in it. This will give us some kind of unwanted state. Can you guys write it into the comment that what is the problem with this statement, with this function call? If you write this function called print name, what is the bad impact that it will have? Just look into and just put that into the comments. So if for those, so let's try to understand what is the problem with this one. The problem with this one is that first of all, when I call this print name function like this, okay, so what happens is that as soon as I call it, the first time the function gets called print name, right? It comes inside this step, it prints hello students. As soon as it prints hello student, is again called this function print name. So second time the function gets called this print name, and it again prints hello students. Right? So it goes from the here to here. Then again it calls hello. Third time it calls hello students. So what we see is again it will go inside call hello students. So this thing will continue happening. The function will keep on calling it one after the another. It will not end. And it will keep on doing till the time it will go out of memory. So in other words, also I can say it will go in the infinite loop. So now this is a recursive pattern, but this is not the right way of writing a recursive code, because if you write this way, it will keep on printing hello student, hello student, hello student for an infinite amount of time, and will keep on doing till the time it will go out of memory and it will simply crash, right? So there is a problem with this, but now we have understood what a recursive pattern is. So the next thing is that how do we write a recursive problem? How do we solve a recursive problem, and what is a common pattern that we should follow when we are solving a recursive question? So before I move on, I have a question that how frequently are questions related to recursions asked in the coding interviews? So Saurabh Malhotra, this question is yours. So I think the recursion is something, a question related to recursion will be asked in every interview, because this is such a foundational concept, right? Even if they ask you a question from the linked list, that might be related to the recursion. If they ask you a question related to the sorting, that might, the underlying base will be the recursion. If they ask you a question of a tree, there's a 100% chance that you'll be using recursion to solve it. So this recursion is so important that, nobody will directly ask you a question from the recursion, but any question that they ask, underlying implementation will be the recursion itself. So that is why this concept is very important. So the next thing that I'm going to talk about, what is the few key points that you have to keep in the brain when you're defining a recursion is very important. So I hope this answered your question, and let's move know how to write a correct recursive code. Let's move on then. No. So see guys, recursion has a very straight way of solving the problem. Okay, any recursive problem that you have, right? Any recursive code that you write, basically a recursion is nothing but a function that you write in which you call the function again. So any recursive function that you write, it will have three things. The first and the most important thing is the termination condition. This is very important. As we saw in my last example, it was not terminating anywhere. It was just going for the infinite loop, right? So whenever you are writing a recursive code, the first and the most important thing that you have to keep in mind is that provide a proper termination condition. Provide a proper termination condition, right? The second important part is the business logic. The second important part is the provide a proper business logic. Like whatever that the logic may be to just print the name, the logic can be do some complex calculations. So you first check the termination condition. If it is satisfying, then you just return out of that function. If it is not, you provide some kind of business logic which that particular function is intended to solve. This is the second thing that you apply. And then third thing is that you call the function recursively again with changed input size. Let's try to understand these three key points using an example. Okay, so suppose my problem statement is that print hello students say 10 times. Suppose this is my problem statement. Okay, so for that what I do, let me write a function. So what I do is that public void, and I say print name. Okay, and in this I pass a input number, so that if I have to print say like 10 times, I'll pass n is equal to 10. If I have to print like 5 times, I'll say like n equals to 5. So I have defined a function. The function name is print name, and it is taking n as the size of the input, how many times I'm trying to print the name, and it is not returning anything, right? So let's try to follow this rule of 3 pointers while defining a recursion. So first of all, I have to look for the termination condition. Okay, so very first thing that we need to write inside any recursive function is the termination condition. So can you guys help me with the termination condition? You can write what should be the termination condition in this case in your YouTube chat, and you can then cross check with your answer whether it's going right or wrong. I'll strongly encourage you guys, if you are there, please try to follow along with me, try to write the code. You can have a pen or paper to write the code, or you can do it in a parallel in your computer. But I strongly encourage you guys, whatever problem that we're solving here, please try to solve in the pen and paper. Okay, so what we do is that we have to first provide the termination condition. So what we write, if if n is less than equal to 0, okay, so if the n value has now become reduced to equal to 0, what you do, I should return. Don't do anything and you just return it. So this is my termination condition. So this will be my termination condition. So if n value is equal to 0, it means I don't have to print any number of times, so I just return it. Or if n value is less than 0, then it doesn't make sense, so I just return. Okay, the second part is that the business logic. So the business logic is that I have to print name. I have to just print name. So I have to just print some statement. So what I do, the business logic is this. Let me use the another color of the paint, so not red. So I write sorry, system dot out dot print, and here I print hello my student, something like this. I suppose I printed. So this is the second part that I've read, which is the business logic, right? And the third part is call the function recursively. Now, since I've already printed it once here, so the next time that I am calling this function recursively print name, what I can do is that I can reduce this n by 1 because I've already printed it once. So this is a very simple example of a recursion in which I have tried to put three things. The first one is my termination condition. This is here. The second one is my logic that I needed to write. And the third one is the recursive call, right? And in the recursive call, you have seen I have reduced the input size. Initially, the size was n, and now the size is n minus 1. Now the size is n minus 1. Let's try to take another example and it will be very clear. Okay. So suppose another example here is, suppose I have an array, suppose 1, 2, and 3. And what I need to do, I need to print all of these elements. I need to first print 1, I need to print 2, and then I need to print 3. Let's try to solve how we can recursively do. So for that, define a function. So maybe, public void and say print array. Okay. And this method is taking input as the array. And I also say that what is my starting index. Suppose this I is my index. Okay. So this is my method. So this is the recursive function that I have defined, and this function should recursively print all the elements of this array. Guys, please try to follow me. Okay. As I said, the first thing that I need to do in this case is that I have to write a termination condition, right? The first thing, blindly in any recursive call, whatever the recursive problem is, you don't have to worry about. The first and only thing that you need to look for is what is the termination condition. Okay. So you guys can, print in the comment section that what is the termination condition here, and then you can check with whether it's right or not. So basically, the two inputs that I've taken here is the array itself and the starting index, right? So basically my starting index will start from here and will move till the end. So it's starting index, it will be 0, then it will be 1, and then it will be 2, right? So once I move beyond this index, I'm literally done. I'm literally done processing the array, right? So my termination conditions would be, once I'm done with all the indexes of the array, I should simply return. So for that, what you need to check, if, so for this, we can, we can write the code, if I is greater than equals to array dot length. Now, what is the array dot length? Array dot length will be here 3, right? Here my array dot length will be equals to 3 because it has 3 elements, right? So an index value I, till the time it is 0, till it is time 1, till it is time 2, it is valid. But if it goes beyond 2, which is equals to array dot length and more than that, in that case, I should not do anything and I should simply return, right? So this is my termination condition, right? The second thing that we need to do is that we have to write a logic. So what is the logic here? We have to print each of the individual elements. I have to print first 1, then I have to print 2, then I have to print 3, right? The simple way of doing is that I just do, I write system dot out dot print ln, and I do simply array I. So now for the given index I have already printed 0, 1. So I have printed it. So this is done. So the next part which is left is the recursive call itself. The recursive call itself, right? The recursive call itself. So when I call it recursively, right? When I try to call it recursively, now what I can do is that I call this print array. I pass array. And now says I index element has already been printed here. So I need to increase it. So I do it I plus 1. So this is another simple example of using recursion to print all the elements of the array, in which I have showed you, I have to provide a termination condition. So this one is the termination condition. This is the logic that you want to print. And here you have called it recursively. You have called it recursively with the increase, this index value has been increased. So whenever you have to, the few important point to note here is that termination condition is important. Then you have to apply the logic. And the third and the most important point is that you have to call it recursively. But whenever you're calling it recursively, this index has to be modified because you've already done with the ith index. So you should move to the next index, right? So I think this will make more sense if we do a dry run of it. So let's try to see, how we can dry run this. So let's try to use this space for the dry run. So suppose I have I have uh, the given array as this 1, 2, and 3, and suppose I call this function like this, print array, and I call this array here, and I call starting index as 0 because the starting index in the array starts with the 0, right? So the first time when the function gets called, right? So first time when the function gets called, right? Uh, so the first time when the function gets called, at that time this print function has the array value equals to 1, 2, and 3, and the value of index is equals to 0 at that time, right? And then it will go inside this. Now if condition y value is equal to 0, array length is equal to 3, so it is not satisfied. So I'll go and print array 0. So what it will do, it will print 1, right? And after that this recursive call again happens. So as soon as it happens, it goes to the step 2. Now in the step 2 also the array value remains same, which is equal to 1, 2, 3, but here the value of I has become equals to 1 because I increased the I and then I put it, right? So again when it goes inside the function, I value is 1 here and the array length is 3, so it will not do anything. So it will again call this method and will print what? It will print 2, right? And then again the recursive call happens. So it will go inside the function third time. Again the value of I is 1, 2, 3, and I value now becomes equals to 2. Now again this if condition will not satisfy because I is 2 and array dot length is 3, so it will not do anything. It will again go and print 3 here, and it will again call recursively again. So again fourth time the value of array is 1, 2, 3, and the I value is now 3, right? So I value now becomes equals to 3 now, right? Now I value is 3 and array dot length is also 3. So this condition gets hit. So termination condition is satisfied, and from 4 what I do, I return. Okay. So what I'm saying, I'm going from the step 1, and then I'm going from step 2 to 3, and then I'm going to step 3 to 4, and then I'm returning. But when I'm returning, I am not returning directly. So what will happen is that after the 4th, I'll go back to the step 3. So I come back to the step 3 here, but there nothing is left. So again, I'll go from the step 3 to I'll go to the step 2. And then from the step 2, again, it is I have here. So it will again go back to the step 1. And finally, from the step 1, it will finally terminate. So another strong point to understand here is that unlike a loop in which it's a one directional motion, you move from the I equal to 0 to I equals to n. In the case of a recursion, it's a complete loop. You first keep on moving down, down, down till you hit a termination state. And then again, you come back to the starting position. And that is the beauty of recursion is. And this I want you guys to understand very clearly because, with all my interaction, 90% of the people don't understand this meaning of recursion. Recursion always, works in a complete loop. It goes from the one end to the extreme, and when it has hit the extreme, it will again come back to the starting position, and it will only terminate from the point where it started. As you can see, it calls the first time it gets called to the second to the third to the finally when it returns the termination condition, it again comes back to the 3, again come back to 2, and again come back to 1. This concept is very strong, and if you understand this concept, trust me guys, this will help you to solve many problems very simply, very easily. We'll again repeat this concept, which I again repeating it, in a recursion, unlike a normal iterative approach, it is a complete loop. You go from one end till the time you hit a wall, that is a termination condition, and when you come, and then you start coming back to the starting position. Only when you reach the point where you started, you finally terminate the condition. And this concept is very important. If you know how to exploit this situation, you'll be able to solve the problems very simply and very easily. We'll take up in another example here, and we'll see how does this make sense. So Gurvinder has the question that what is the benefit of the recursion and what is the difference between loop and the recursion. So I'll take up this question. Just bear with me a few more minutes. We'll take a few more examples, and by that time you will yourself be very clear. How strong this recursive concept is and why people go beyond the iterative and they try to look for the loops. So Smriti has a question like, will recursion always provide better time complexity when compared to the iterative solution? No, it's not like that, that recursion will provide you a better time complexity than the iterative one. But Sometimes in certain situations, if you try to solve the problem using iteratively, right, the solution will not be very intuitive. If you want to solve it very intuitively and a very simple way, very clear way, that time recursion will make more sense. So we have one example and we will try to solve it, and I think that will make your this concept much clearer. Yes, Vipin, so we'll be talking about this complete loop again in the another example, and I think that will make your concepts clear. So let's take another example. We'll try to just extend this one. So suppose I have two problems to solve. I have, okay, and this part of the code I'll use for writing the code, and here I'll use for the dry run. Okay, so this is a dry run section. This is a dry run section. Okay, and above it, so suppose I have an array 1, 2, and 3, and I have to actually print all the array in the same order, and I have the same problem, array 1, 2, 3, and suppose I have to print in the reverse order. Okay, so same similar problem, but two different requirements. I have given a same array, and in the first case I have to print in the same order 1, 2, 3, and in another case I have to print 3, 2, 1. Okay, okay, so for the first part we have already seen the code. So let's try to quickly write the code of it. So it is, public void, and then say print, and I pass array, uh, you know mm, so we basically pass int array and int index. Okay, and for here also I'm also given the same. So here also, for example, I have been given the same methods definition, public void print int and int I, right, and this is my method, and this is a method. So exact same method definition, the name of the method is also same, the arguments are also same, but in this I have to apply the logic in such a way that I print 1 first, 2 second, and 3 last, and this I have to print 3 first, 2 second, and 1 last. Okay, and we'll see that how with the beauty of the recursion and the last statement that I said, recursion works in a complete loop, how that concept, if we use the same function, we can get the two different results, right? So let's try writing the code. The first one I have already written, so I'll just quickly complete the code of it. So first of all, we write, the first thing that we write is the termination condition. So termination condition will be what? If array dot, length value greater than equal to I. So if the value of I is greater than equal to array dot length, I do nothing, but I simply return. So this is what I've written. So this is my termination condition. Then I have to write the logic. So the logic is system dot out dot print ln, and it prints array I. Okay, and then I call the recursively again print, and I call array, and I call I plus 1. Okay, and if I do this, it will print me 1, 2, 3. Let's try to see quickly. I'm again doing a dry run of the same thing because I feel that this is something which you should pay great attention to. So if you missed understanding the concept in the last question, please understand how I'm trying to do a dry run. Okay, so first of all, when the first time the function gets called, okay, at that time we are calling the function like this, print array and 0. This is how we are calling the function. So the first time the value of the array is 1, 2, and 3, and the value of index is equal to 0, right? All of you agrees? So as soon as it happens, it just try to check if the if condition is valid or not. If condition is already valid because array dot length is 3 and I value is 0, which is satisfied. So I go and print this array I. So I go and print 1, right? And then it goes, then again this function got recursively called. So for second time the function gets called, the value of I remains same, which is 1, 2, 3. And the I became value equals to 1 because I incremented it when I'm calling it, right? So again it comes inside this and I calls, so when it comes to one step 1, 2, it again prints 2 and it goes to the step 3. In the step 3, again value of array is 1, 2, 3 itself, value of I has now increased to 2. It will print 3 here and it will go further down, step 4. And here it is 1, 2, 3, I value has now equals to 3. And when I value is equal to 3, this condition gets true, and here now it returns. And this is what I mean to say that it is a termination condition, or when it is hit the 1. Now as soon as it is done, it will again try to come back. So from the step 4, it again comes back to step 3. So those guys who have a confusion that why I'm telling it as a complete loop, try to understand this. So I'm coming back from the step 4 to the step 3 here, right? Again, when I come back to the step 3, I'm here. After this, nothing has to be done. I'm already at the last. So again, I go back from the step 3 to the step 2. And again, I go from the step 2 to the step 1. And then I finally return. So since I'm going back to the step 4 and then again coming back to the step 1 and then finally returning. So that is why I'm calling it as a complete loop. And in this question, when I write the code like this, this will print me the answer in this format. Now, using this concept of the recursion and also the hint that I have given you that, recursion happens in a circular loop. It goes to the end and it again comes back. Can you guys help me understand what change should we do in this logic that this now with the same method name, I start printing it in the reverse order, So you can try with your pen and paper. And if you have any suggestion, you can put it on the YouTube comments. We'll try to solve it. So again, the termination condition remains the same, right? So the termination condition remains the same. So it will be if array dot length is equals to I, then I simply return. The termination condition remains same because once we are done with the, if we are moving from this direction to this direction, index from 0 to 2, and once I have reached this position, it means I have covered all the elements, so I can simply return, right? Now the second part is that now what can you guys guess by now that what was the change that we needed? If yes, then you can just put it into the comments, and if not, just try to follow along. So the only change that we need to do is that instead of printing first and then calling it recursively, what I can do is that I first call the recursive function print I plus 1, right? And I do a print later on. System.out.println array I. So the difference between this problem and this problem is only that I have called the recursive function first and then added a logic. And in this, I have added the logic first and then I have printed. And let's try to see a dry run of this and see what difference it will make, right? So again, I'm calling this function like print array and 0. Okay, so the first time when the function gets called, the value of array, and guys, please pay very strong attention to it. The value of array is 1, 2, 3, and the index is equals to 0. Now, as soon as I came inside this, this termination condition is not satisfied. And the next thing that I do is that I simply, and the next step itself, I call it recursively, right? So it will go from the step 1 to step 2. So it goes from the step 1 to step 2, and again in the step 2. And here, if you see, there is no print statement in between, so it will not printing anything as of now. So it has just went recursively inside that print method. So now again the value of array is 1, 2, 3, and the value of I has now become equals to 1. Okay, and then again when it goes equal to 1, this if condition is not satisfied because I is 1 and array dot length is 3. So again this calls recursively third time. Again the value of array is 1, 2, 3, and array I value is equals to 2. Again, it calls recursively with the increased value of I. And the fourth time, it calls array equals to 1, 2, 3, and the I value is equals to 3 now. Now, as soon as I value becomes equals to 3, it hits this termination condition. So now it returns back. It tries to return back from the step 3 to the step 4, right? Now, when it returns from the step 3 to step 4, it is here, right? And the step 3, this statement has still to be executed. So here the value in the step 3, the value of I was 2. So what it will print? And now when it is returning, it will print 3. And after printing, it will again go to the step 2. In the step 2, again, this print statement is left. The value of I at the second position is 1. So at that time, it will print 2. And then again, it will go to the 1. And what it will print? It will print 1. And then finally, it will terminate. So what we have seen here is that in this case, since I have put, the recursive call first and the business logic after the recursive call, while I'm returning back from the loop, I am printing it. So this is again a very strong concept, which I feel most of the people don't utilize it when you're using recursion. So, the one key takeaway from this is that if I'm writing a recursive function, The three things are important. The first one is the base condition. If you write a base condition, then only you can terminate. So that is essential. That will be the first thing that you need to write in a recursive code. The second thing is that how do you decide when to put logic first and then recursion, or recursion first and then logic. So in the case, if you have to apply the logic in the same order in which the data structure is, you write the logic before the recursive call. So for example, in this case, 1, 2, 3, I have to print in the same order: 1 first, 2 second, 3 third. Then I added the logic before the recursive code. But here in this case, when I have to print something in the reverse order, the only thing that I need to do is that add the logic after the recursive call. So what it will do is that while going down, it will not do anything. But when it's returning back, it will pick up the logic and start printing it. So that way, the same code, you could reverse anything very elegantly. So this is the beauty of recursion. As if you use recursion, many of the problems like reversal and all that stuff, which becomes little complicated when you're using iterative approach, things becomes better, things become easier. Cool. I hope this makes sense. Please let your doubts in the comments if you have any. So I have a question from the Sanjeev in which he's saying, give an example of tree having recursion. So tree is not a scope, but I can quickly, I can quickly give an example. So for example, if you have a tree like this, 1, 2, 3, 4, 5, and 6, right? And somebody tells you, can you write a pre-order or post-order, the in-order traversal of the tree, right? So for that, if you go for an iterative approach, it will be a little complex. You will have to use stack data structure. You have to write, for loop and all that stuff. But if you just use some kind of recursive thing, it becomes very simple. It becomes very simple. So for example, if I have to write a pre-order of this, I can simply write, public void pre-order, and I say tree node root, right? First of all, the base condition, right? Or the termination condition. So if root equals to null, I just return. I don't do anything, right? So this is the first thing. The second thing is the logic that I have to write. The logic is to the pre-order fashion. So I have to print it. So what I do is that I do SOP, root dot get data. This is my business logic. And then I have to call recursively. So I have to print this also recursively. I have to print this also recursively. So what I do is that I do pre-order root dot get left, and I do pre-order root dot get right. So basically the idea is that if you use recursion, see, in just like 4 lines of code, you have been able to solve this so elegantly. If you try to do the same thing in the iteratively, it will become little complex. So the idea is that the utility of recursion is great. It's a very foundational concept and it's very important. So I'll just quickly repeat what all concept that we have studied so far. So one is that, first of all, in any recursion, you have to first write with the termination condition. And then second and third, it can be logic and recursive call, right? Any recursion goes in a complete loop. So it will go to the step 1, it will go to step 2, it will go to step 3, and maybe then it hits the termination condition. And once it hits the termination condition, it will again come back to the step 3, it will again come back to the step 2, and then it will again go to the step 1, and then finally returns. So anything that you write, anything that you write before recursion, whatever logic that you write before recursion, it will get executed during this time, right? And anything that you write after recursion, that will get applied when I'm coming back. So it will apply here, it will apply here, it will apply here. So we have taken an example to solve that. So I hope that things are clear. Any other doubt you have, guys, feel free to keep commenting on the comments. So yeah, so I think the next point that I want to cover on is how this magic is happening, how this magic is happening, right? I think most of you guys would be curious that once it is moving from the step 1 to step 2, step 2 to step 3, step 2 to 4, why it is not leaving from here? why it is coming back here, then it is coming back here, it is coming back here, and then only finally returning. I think this is one of the very common question you guys must have. And I think if you guys are having this question, that I think you are on the right path, because I want you guys to be little inquisitive and little curious, because unless until you question the things, you hit the boundaries, you will not understand it. So let's try to understand, how internally the recursion works. Okay, so, and this will make your doubts clear. So basically, recursion, to support recursion, right? Uh, we need a data structure known as the stack. Now, stack is something which we're not going to cover and talk more in the details in the coming session. That is because that is a separate topic. But just to give a small quick reference here, that stack is a kind of, we also call it first in, last out, or last in, first out of kind of data structure. So for example, a practical example of that, if you ever go to the restaurants, they will be keeping the plates there, right? So you have one plate, then you have another plate, then third plate, then fourth plate, right? So whatever plate that was kept last by the waiter is the one which the waiter, if keep is last, then the customer will pick it the first, right? This is one example of a stack, right? So stack is basically a first in last out, or last in first out kind of data set. So whatever that you inserted last in the stack will something which will come out the first. This is the only thing that you need to understand as of now, what the stack is, and later on we'll talk in details about the stack data structure. So normally, in order to facilitate recursion, underlying data structure that is used for that is stack, right? And this is what it powers it. So normally in any language, whether it's a Java, Python, or any of the language, whenever you execute any method, right? Whenever you execute any function or a method, a call stack of that gets created. Many of you who are already working might be already aware, and for those students who are still starting and you're learning these things, whenever you execute any method or any function, a call stack gets created. Call stack, we call it. And call stack is nothing but a stack kind of data structure, stack data structure. So for example, if a stack data structure is like this, suppose I have a stack this. So suppose I inserted 1, then I inserted 2, then I inserted 3. If I have to say remove anything, the first thing that will get removed is 3, and it will get removed from here. Then again say remove one element, then last element which was added was 2, so 2 will get come out, and then finally the 1 will come out. So this is how the stack data structure works. Now let's try to see what happens in this case. What happens in this case? So let me rub this one, and then I think I will have little more space and we'll do it more clearly. So again, let's take the example of the previous problem itself, because that is simple, but that is very important, very conceptual. So the problem was I have an array 1, 2, 3, and output should be 3 first, and then 2, and then 1. And for that, the code that I have written, I'll again write the code quickly. So it was public, sorry, let me use another color so that more contrast on your screen. So suppose it is public void, and suppose it is print, and I take int array, and I start take index I. First of all, I write termination condition. So if I is greater than equals to array dot length, do nothing, just return. And second is that recursive call. So what I do is that print, and I call this function recursively with value of I incremented by 1, and then I call the logic. Logic is print things, system dot out dot print ln, and I do array I. Right? This is how I do it, right? And now let's try to see what internally happens. So as soon as I call this function print like this, print array and 0. As soon as I call this function, what happens is that a stack gets created like this. So I'll create a stack in another color. So a stack gets created. This is known as the call stack. This is known as the call stack. Okay. So a call stack, the call will keep on happening till the time the stack is not empty. So as soon as the first time the function gets called, the first time when the function gets called, so the first time when the function gets called, the array value is equals to 1, 2, 3 and I value is equal to 0. So this metadata gets stored in the stack. So it will get stored something like this. So corresponding to 1, the array value is 1, 2, 3, and the value of I is equals to 0. This is one record that gets stored in the stack. Okay. And then as soon as I hit a termination condition is not satisfied, this again calls recursively. It again goes to the step 2. And now again the value of array is 1, 2, 3, and the value of I is equal to 1. So another entry gets added into the stack where it is the second time, and the value of array is same 1, 2, 3, and I value is equals to 1. So that gets stored into the stack. Then again it calls recursively again. It went to the third time. Array value is 1, 2, 3. I value is equals to 2. Again this gets added, another entry in the stack. 3, it is 1, 2, 3, and I value is equals to 2. Right? Again it goes back fourth time. At this time again the value of array is 1, 2, 3, and I value is 3 now. Right? So again this gets created. Fourth time, 1, 2, 3, and then I value is equals to 3. Now as soon as I value is equal to 3, now it hits the termination condition. It is saying the return for the first time. So as soon as it says the return, the last entry, this function call actually gets returned. This return is just for the last function call. It is not for all. So as soon as it does the return, this gets come out. This comes out. Okay. So this comes out. So this entry gets removed. Okay. So first what will happen? This entry will get removed. So this will get deleted. This whole thing will get deleted. Okay. And then it will come after this, the topmost is 3, 1. So I came to the third stage, right? I come to here, this third stage, right? In the third stage, the value of I is equal to 2. And I still have to do this thing. So I go and print 3 first. So I will print 3 here, right? I'll print 3 here. And again, as soon as it's done, now everything is done. So this will also get taken out. So this will also come out of the stack. Now it will move, the topmost is now this one. So it goes to this. And here again, this print function has to be, so 2 gets printed. So this part also now gets removed. And now I'm only left with the first one. And once this first also printed, this also gets removed. So it's because of the stack, is that actually whatever that came last will come out first, and whatever that came first will execute in the end, because of which this gives this a nature of a complete loop. You go till the end, then you start coming out, and then only you are fully done. So unless until this call stack is done, you cannot complete the execution. So that is why it goes to the step 1, it goes to the step 2, then 3, then 4, and then again comes back to 3, then again comes back to 2, and then again comes back to 1. This concept is very important, guys. If you understand this concept, please, if you're not getting it, because of time constraint, I cannot keep on repeating, but what you can do is that after this video is done, you can always go back and rewind, and please listen to this concept. Trust me, 99% of people don't realize what this concept is, and they are only using 30% of how strong the recursion is. If you understand these things, and if you're able to use it 100%, I think your concept will be really great in the recursion. Does that make sense? Cool. So I think most of the people have the question around this, and this should have got answered with this one. This should have got answered with this one. Cool. So a very nice point from the Mariam. Our situation gets satisfied itself by just, the question is that our situation is satisfied with only I equals to array.length. Why have I put something like, greater than that? You are true. We are only happy with this one, but I'm just putting it to avoid any kind of error situation. So for example, in the starting itself, if suppose somebody call this function like this, print array and something called 5. So again, this is not valid, right? So even to rule out these kind of situations, because in the case, if I just added I equals to array.length, in that case, if condition will not hold true, and it will go and erroneously, it will go and call recursively, right? So in order to avoid those kind of error input, I have also added, greater than equal to, so that those cases can also be covered. So this is how you have to think about whenever you have to solve a problem. Don't just solve the problem in hand. Try to think futuristically. Try to think about all the boundary cases, and then only you can separate yourself from the rest of the people. See, guys, today is the world in which there is no scope for average people. You have to make a difference from your solution to the other solution. And how do you do that? The only way of doing that is that try to think futuristically, try to think about the scale, and try to think about the boundary cases when you're solving the problem, right? So if you just use equal to, you're just trying to solve this problem statement. But if you also think about the boundary cases, the errors or the invalid inputs that can come to a problem statement, you should consider those things also. Cool. I hope this is making sense. So Vishal, your question is in perspective of coding. Please explain the practically. So I hope this question is mostly around the recursion. So again, I'm coming back to the next question. I think this your answer question should get answered with that. So another question, and I think a doubt among the people is that say the same question. People say that same most of the problems can be solved by both iterative means either the for loop or while loop, or through the recursion also. Most of the time the problems can be solved with the both iterative as well as the recursive approach. Then why recursion is so important? The reason being is that as I tell you, right, the flexibility that you have in the recursion, that you can apply some operations while you are going down and while coming back also, that is not there in the iterative, because iterative is a one-way solution. You all can move in one direction, either it in the reverse or in the forward direction. So that is one of the limitation with the iterative. The second is that many of the situations, for example, take example of tree or take example of graph. In these kind of data structures, right, since the arrangement is not linear, right, it's more about the pattern, right? Because for example, in the tree, every node will have the child and every child will have another child. So it's more about a pattern, right? So in the questions where it's mostly around the pattern, iterative becomes little complex, because you have to set the pattern in a linear fashion. But if you do the same thing in the recursion, becomes very we use recursion because in many of the complex data structures where the pattern is not very linear, it's kind of repetitive in certain pattern. I think intuitively you will find it that recursion is much better to use and it's simpler to understand. It's very simpler to understand. So for that sake, I'll just post this question right now, and I'll request you guys not to look on the internet, because if you look on the internet for this question's solution, the whole purpose of it will be defeated. Because if you solve this problem using recursion, you will understand that how strong the concept of recursion is, first thing. And secondly, why I'm saying that recursion gives you an intuitive and clean solution than the iterative. Okay, so the problem goes here, and I think that will be in the seat also. But for those people who are yet not registered, I request you to come and register on the Great Learning site. But if you're still not done, you can still try to solve this problem statement. Okay, so the problem statement is okay. This is a very standard problem. I think most of you have already seen it. Normally, when you see the solution of this, things looks very simple. But when you try to go and do on your own, sometimes that is when you start struggling, right? So I want you guys to solve this problem. So problem statement is like that. You have three towers. Suppose I have a tower 1, I have a tower 2, and I have a tower 3. Okay, and on each of these three towers, I have a different coins. So suppose this is a coin. These are suppose the coins, and I have say n coins. I have n coins on a tower T1. And how the coins are arranged? The coins are arranged in such a way that the coin with the largest diameter is at the bottom, and the coin of the smallest diameter is at the top. Right? So we have three towers: tower 1, tower 2, and tower 3. In the tower 1, I have n coins arranged on the top of each other. The bottommost coin has the largest diameter, and the topmost coin has the smallest diameter. Okay. Now my task is to solve this problem statement by using the recursion. So I have a tower 1, I have a tower 1, I have a tower 2, and I have a tower 3. So all the coins from the tower 1 should get moved to the tower 2. So it should be like this. So this is my final first state, and this is my final state. So all the n coins from the tower 1 has to be moved to the tower 2, right? This is the task. And the constraint are that only smaller coins can be kept on the top of a bigger coin. A bigger coin cannot be kept on the top of a smaller coin. This is one constraint. And second is that at a time only one coin can be moved from one tower to another tower, right? So I cannot move like 3 coins together from tower 1 to tower 2. At a time only one coin can be moved, and whenever we move one coin, we count it as one move. Okay, so the problem is, how many moves do you need to take to move all the n coins from the tower 1 to tower 2 using tower 3 as auxiliary? This is the problem statement. This is a very classic tower of NI problem. And if you try to solve this problem with the concept that we have learned in the today's session, and I will discuss this as a first problem in our next session, which is tomorrow. Okay, you will actually appreciate that how strong the concept of recursion is, because if you try to solve this problem using iterative approach, trust me, it becomes dead complicated. But if you solve the same problem using recursion, it will be solved in only 3 lines of code, and it will be very intuitive. So I'll encourage you, all of you, to please solve this problem on your own. Don't look at the internet, don't look for the solution, try to solve it on own. Totally fine if you're not able to find the solution. We'll talk about it in the tomorrow session with all the concept that we have learned today, and we'll try to build the solution on the top of it. And that case, I think most of you guys who have a doubt that when to use recursion over the iteration, why I say that recursion is better than the iterative approach, and it's more, logical, and it's more intuitive, things will get very clear with this particular problem solving, right? So we'll take this as a first problem in the tomorrow session, and we'll discuss further about, why I'm saying that recursion is such a strong concept, and you have to be very clear about it if you want to have a very strong foundation in data structures and algorithm. So with that, I like to conclude, because I think we have already crossing our time. I'll try to take few questions more. So Yash is saying that, does recursion uses only stack? Yeah. So no, the recursion only uses the stack data structure internally, because this is how, how the internal call stack has been defined in any operating system. So whenever you call one method after the another, it always creates a call stack. The reason being is that the last one which get executed is the most important thing, right? For example, you have done step 1, step 2, step 3, and again coming back, the step 3 is the last one which I'm more interested in. And only stack provides that first in last out, or last in fast out kind of data structure. So the stack makes more sense there. Any other question, guys? If you have, I'll be more than happy to answer those, but I'll request you guys to please register. I think I couldn't get time to discuss the seat 1 today, and also I have deliberately not done it today because I feel still few of the folks are still registering. So I'll encourage each of you guys to register on the Great Learning site about these sessions. You will be getting assignments before, after every session. And from the next session, it's like initial 10 minutes, I'm planning to, go through the previous seed questions if you have any. What you guys can do is that, before the start of the session itself, you can start putting your doubts, like, that I know from beforehand itself that what are the and we can properly plan it. So please do register yourself and try solving it. Try to be continuous with the pace of the class. And yeah, that's all. I think that's for the day. All the best, guys. Let me see if you have more questions. If I is too large, should we avoid recursion? So again, this is something, again, we are, as we said that, and I'm going to talk more about it in the tomorrow session. Since the recursion, the underlying data structure that uses is stack, right? So obviously, whenever you are using a recursion, you are using some extra space to maintain that stack. So in the terms of the memory, definitely, the recursion takes some extra space. So if you have some memory concerns, in that case, you can think of preferring over the iterative solution than the recursive. But if the memory is not a concern, which is today's the cases, we are talking about the big data world, right? In which we are storing like huge amount of data with the great replication strategy. So, the storage is one of the most cheapest thing available today. So that is not a concern. I think iterative is the way to go. It's much simple. There's a principle in software development which is known as KISS, right? And it's not KISS that you do in your romantic relationship. It is keep it simple, stupid, right? So as simple as you can keep the things in your software development, your things will be more robust. It will be more scalable. So this recursion brings simplicity into the picture. It makes your code look very intuitive, and you can solve the same problem in minimal number of lines. I hope that makes sense. Cool. So Sanjeev is asking that, so basically, I think I introduced myself in the beginning itself. So I have close to like 9 years of experience. I'm a passer from IIT BHU, and during this 9 years of experience, I got the chance, fortunately, unfortunately, to work into the different sectors. I started working for database giant like Oracle. And then I moved to the payment domain again for the PayPal, which is the market leader. So payment has PayPal has a presence in more than 150 countries in the terms of money wallet. So that is the market leader in that. Then I successfully worked for Amazon, and then I moved to Walmart e-commerce domain. And now I'm working for world's largest professional network, which is LinkedIn. So I've been able to touch most of the pillars, and very fortunate to work on various scalability problems. So with all these years of experience, one thing that I have realized that is very important in your career growth is data structures and algorithm. Not only for cracking interviews, but also as a complete developer. When you're writing the code, to get the confidence to write the more optimized code, I think this plays a great role, right? So data structures and algorithms is something, if you are someone who's trying to make a mark in this IT industry, do something great. If you want to see yourself in a zoo of architects someday, I think this is one basic foundation that you should definitely work on. You cannot skip data structures and algorithm and move on. So try to please do work on it. I think this is the high time that you should do it. And yeah, so this is what I can tell you. And throughout these sessions also, I'll be sharing more of a detail, the experience from my life, the learnings, and the mistakes that I did, which I don't want you guys to do it, right? So we'll try to talk more about that in the coming sessions. And I hope that answer your question, Sanjeev. Any other question, guys? Are we good? I think we're already well above the time, so I'll stop now. So thanks a lot for joining, guys. Please share it with your friends. I think this is a very great opportunities. Thanks to Great Learning for bringing me on. And I think we are providing a very nice solution to all the students, to all the professionals, to the people who are again wanting to learn data structure again. And share among your friends, guys, because this is free and you can make the best out of this quarantine time to learn the new things. And I'll try to bring more industrial perspective into it, the more practical things, and the areas which I feel the people or the students have ignored. I'll try to bring those, focus on those points, so that you don't miss on those points. Said that, that's all for the today. We'll see you again tomorrow, guys, at 7 p.m. Until then, take care and stay safe, guys. Stay indoor and stay safe. Thank you. Thanks a lot.